I need to solve. So what should I do? I cannot combine them. So my other option is, and the only option is to I have to factor. I have to factor out x, 2 natural log 5 minus natural log 3, because negative natural log 5 minus natural log 3. Now I divide. But I cannot, I'm not saying that you said that, but I can never divide by the variable. So negative 3 natural log 5 minus natural log 3 over all this. And do not try to simplify anything. It's impossible. We cannot simplify terms. Okay, now you really have to be careful. If you want to approximate this so you can check, you really have to be careful how you enter it in the graphing calculator. So how do I enter it? So parentheses, negative 3 natural log 5, close, minus natural log 3, close, close, divided by, open again, 2 natural log 5, close, and minus natural log 3, and close, close. Now when I press enter, I get whatever. I don't trust it, and this is what I need to do. Now, be careful, because if you want to enter the previous answer, then for this situation, you have to check on this. Minus 3 raised to x minus 1 is 0. This is where I check, not in this. It's the same thing with this. If I move 3 to x minus 1 to the other side, I get this. So I prefer to check in this because I want to use the previous answer for both. Otherwise, you can't. So then I have 5 power in parentheses 2 times the previous answer and plus 3, close, and minus 3 power parentheses previous answer, because it's the same thing, it's still right there waiting for me patiently, minus 1, and close. Now when I press enter, I may not get 0. I may get something extremely close to 0. So the calculator sometimes does not, I'm not going to say it doesn't behave, I'm just going to say that sometimes it may have a tolerance or some error. I hope to get the 0. So I did. So obviously the negative 2.7954, negative 2.7954 approximately is the correct answer. But again, if you want to use this feature with the previous answer, if I do it piece by piece, I will not be able to use the previous answer, because in the next line with 3, it will take the answer from here. It will not take this answer anymore. You cannot go to previous. Okay. So that's why I'm saying that this is maybe the most cumbersome, maybe not difficult, but most cumbersome, because you saw it took me, of course, I write big, I write with a marker, but look, it took me a whole page to work on this problem because of distributing, because I had to move terms around, because then I had to factor, and then I had to finally divide. Okay. Let me know if we need anything else. Yes, we can choose from 43 to 48. Let's work on one problem like that as well before we move on to log equations.
Can we do 43?
Of course. So let's take a look at 43. In 43, we have e to 2x minus 3 e to x and plus 2 equals 0. Good pick. So let me explain something here. This e to 2x is the same thing with e to x everything squared. How come? Copy the base, multiply the exponents. So if you realize that this, if I denote e to x by t, let's say, this is t and this is t squared. If e to the x is t, e to the x squared is t squared. What am I saying here? I'm saying that this is quadratic in form. What does this mean? T squared minus 3t plus 2 equals 0. And this I know how to factor into t minus 1 and t minus 2. So I have two options for t. T equals 1 and t equals 2. But now I have to go back and replace t by e to the x. So I have two equations, e to the x equals 1, and the second equation, e to the x equals 2. So let's go back before we finalize it. This is not finished. Okay. So I realized that when I looked at e to 2x, I know that e to 2x is the same with this. Why is this important? Because I realized that this is t and this is t squared. So this is very easy to look at, t squared minus 3t plus 2, because I know how to factor. I know how to get the two possibilities for t. But since t is e to the x, this equation is e to the x equals 1, and this equation is e to the x equals 2. I know how to solve these because I apply natural log to both sides, but here there is no need. E to the x equals 1 means which power do I raise e to get 1? There is no need for, this is a simple situation. There is no need for applying natural log. You could, but there is no need. We know which number we raise to. We know what power we raise e to get 1. What power would that be?
0.
Exactly. Here I will apply natural log, and this is x equals natural log 2. E to 0 is 1. So we exhausted all possibilities for exponential equations. The easy ones with the same base on both sides, and the not so friendly ones with either factoring or applying log to both sides, and or simplifying, or millions of steps. We exhausted all possibilities for exponential equations. Are we ready to move on to log equations? When it comes to log, remember, log has restrictions. Log is not friendly. Not friendly. So I have to be very careful. The same thing with the square root equations, right? Radical equations. The same thing with rational equations. I have to be careful. I never said anything here because exponentials are friendly. They exist everywhere, but log does not. Okay, so let's start. Log equations. So there are two things that I have to mention before we choose the first example. Two options. One option, you always check the prospect solution. Or solutions back in the original problem. Original equation. I don't like this. You can choose it. It's available to you. Oops. Number 2, I prefer the second option. I always state the domain. You have to choose one or the other. You don't have to choose this. You don't have to be consistent. On some equations, you may use this. On other equations, you may use this. It's up to you. But you have, at any point in time, to apply one or the other when you solve a log equation. Okay, and I'll show you what I mean. So they're on the next page. And we have 49 through 92. So let's choose 49 through 92. Let's take it slowly. Let's choose, or I will.
Can we do 65?
Yes. Let's look at 65. In 65, we have natural log of the square root of x plus 3 equals 1. Perfect. Because I don't like this method, and I like this method, I look at the square root first of all. The square root should be greater than or equal, the quantity should be greater than or equal to 0. However, because it's inside of natural log, I can only use this. Natural log, as we know, it cannot be applied to 0. So x greater than -3, meaning when I finish solving this equation, if the answer is not a number strictly greater than -3, I'll say no solutions. If I find an answer that is strictly greater than -3, not -3, then I'll say that's the solution. Good. Now remember, we said that any log equation can be converted into an exponential one. Can anyone tell us how to convert this into an exponential? That was that very, 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 very important concept in this chapter. Being able to write or convert a log equation to an exponential and an exponential into a log. So, how do I convert this into an exponential? Anyone, please? From last time, anyone remembers how to change, or convert a log equation to an exponential? What is the base here? Can anyone tell us what is the base? What is the base of natural log?
Would the base be 1?
E. There is no base of 1. There is no 0, there is no 1, there is no negative. Natural log is, again, let's take a look. It's the same key with e to the x. And there is a reason why. Because natural log and e to the x have the same base. So, this is base e, we don't write it. So e to the first power equals this. So e equals the square root of x plus 3. We just reviewed this a minute ago. What should I do to both sides in order to solve now this radical equation? what we need to do to both sides to solve this equation. Anyone remembers how to solve a radical equation? We solved these equations a couple of months ago. Because the index is 2, we have to square. So then x plus 3 equals e squared, or x equals e squared minus 3. Now, if this number is not greater than -3, which it is, but if it isn't, then I'll say no solutions. If it is greater than -3, then this is it. So, with the graphing calculator, we check. E squared is right here. And then we subtract 3. And this is definitely a number that is positive. So approximately x equals 4.3891. Any questions on this problem? Okay, let's choose another. Anything else? This was 65. Are we ready to pick another? If not, I will. Okay, I will pick 71. In 71, we have log base 2 of x plus 2 minus log base 2 of x minus 5 equals 3. Okay, because I prefer stating the domain, I will state a domain here for x plus 2 has to be strictly greater than 0. For this, x minus 5 strictly greater than 0. This is greater than -2, and this is greater than 5. So remember, here is 0, here is -2, and here is 5. So open, of course, for both of them. Greater than -2 is this, and greater than -5 is this. The +5 is this. And we have to choose the common territory, the common domain. So domain 5 to infinity, where both logs are correct. Okay, so if I do not find a solution that is strictly greater than 5, the equation has no solutions. So I have to condense. That's why we condensed about an hour ago. So then this is the same with log base 2 of x plus 2 over x minus 5 equals 3. Now this can be converted into an exponential equation. Can anyone help with converting this into an exponential equation? How do I do that? Can anyone help with converting this to an exponential? Yes? No? The base raised to this number equals this. So 2 to the third is 8 equals x plus 2 over x minus 5. This is a proportion. I will cross multiply. 8x minus 40 equals x plus 2. I will bring x here, and I get 7x. I will bring 40 to the other side, and I get 42. And then x equals 6. Is it true? Yes, it is. Because it's a number greater than 5. You still want to check? We can check. 6 plus 2 is 8. 6 minus 5 is 1. This will be 0. Log base 2 of 8 is indeed 3 because this is 2 to the third and I bring the power in front. But for me, it's easier to state the domain and just look at the domain, check against the domain, instead of, because I may forget to go back and check. But if I have the domain in front of me, most probably I will not forget to check. Okay, any questions on this problem? Okay, let's choose anything else from log equations before we look at word problems. Anyone would like to pick another problem, another log equation? Anyone would like to pick another equation? Yes, go ahead, Christy. Which one?
Can we do 90?
Yes, of course. Let's look at 90. Very good. In 90 we have log base 2 of x minus 1 minus log base 2 of x plus 3 equals log base 2 of 1 over x. Notice that the domain has to be stated before you condense. I start with the domain. Once you condense, the domain may or may not be this. So please remember the domain has to be stated on the raw equation. Always. Don't try anything. So x minus 1 has to be greater than 0, which means x greater than 1. X plus 3 has to be greater than 0, which means x greater than negative 3. 1 over x has to be greater than 0, a positive over positive, so then x has to be greater than 0. Because only if this is positive, positive over positive will be greater than 0. Okay, so then from here to the right of negative 3, to the right of 0, and to the right of 1. So this is the domain. So domain 1 to infinity. If whatever, when I finish, if I don't get a number to the right of 1, the equation has no solutions. Now I'm ready to condense. Since it's a difference, then I have log base 2 of x minus 1 over x plus 3. The one with the minus in front, its quantity is coming from the denominator. Equals log base 2 of 1 over x. So I saw students are crossing out. No, we're not crossing out anything. We are thinking 2 logs in the same base are equal. What has to happen? And the answer is these two quantities have to equal each other. If 2 logs in the same base are equal, then these two quantities have to be the same. So from here, x minus 1 over x plus 3 must equal 1 over x. Again, this is a proportion. I will cross multiply. X squared minus x equals x plus 3. It's quadratic. Everything has to be taken to one side. minus minus x minus 3, x plus 1. I have from here that x is 3, and I have from here that x is negative 1. Wait a minute, wait a minute. Only solution. Only x equals 3, because it's a number greater than 1. Very good pick. It was a very good problem to work on. Any questions? Any questions? So again, don't cross out the log. 2 logs in the same base are equal to each other only if the expressions are equal. Otherwise, if this is 5 and this is 3, they will never equal each other. So these two have to be the same. Good pick. Do we need anything else? If not, I'd like to work on a word problem. Of course, everything else till the end of this chapter deals with the same thing. Log and exponential equations, but now inside word problems. And that would be the end of the chapter. So, do we need more logarithmic equations? Or we move on to word problems?